you have over there two arrows. Okay, one arrow that is red and the other one that is green. And I promise it's not because of Christmas. That's not the reason. Okay, so a vector. I want you to imagine that a vector is an arrow. Okay, when you throw an arrow, I mean, if you play games in your phone, in your tablet, you know that an arrow is something like that. And if I'm throwing that arrow, this arrow is going in this direction to the right and it's going up. Okay, that's what you can say about the arrow. Okay, if you throw it in this direction, for example, the arrow is going left. It's not going up or down, it's just going left. And for example, if you throw an arrow in this direction, you can say that the arrow is going to the left, but also is going down. Okay. Now, with this, I want to show you that a vector can work as a right triangle. Let's say that I give you these two vectors. This vector that is 100 Newton and has an angle of 40 degrees, and this other vector that has a value of 80 Newton and has an angle of 30 degrees. Okay. As you can see, those arrows are going in kind of the opposite directions. Okay, one is going to the right, the other is going to the left, but both of them are going up. So take a look. Every arrow has two parts. Okay, one part that is called a component. One of those components, this horizontal component, is going to the right. Okay, the reason that is going to the right is because over the x-axis. And as you can see, the arrow is pointing to the right direction, but also is going up. Okay. Now, besides that component, it has another component, the vertical component. This vertical component is showing you how the vector is moving vertically. Vertically, this vector, this arrow is going up. Okay? So, we can say that every vector is going to have two components or two parts. A component, I'm going to call this vector A. So this component here, I'm going to call it AX. The component X for the vector A. And this is going to be my component Y for my vector A. Now take a look. Vertically, as I was saying before, this vector is going up. Okay, so you can put the arrow over there to indicate the direction at which it is going. The vector has a component x that is going to the right, as you can visualize. Okay, so if you extend this, you will be going to the right. Okay, the vector is going to the right. Now, because x is going to the right, I want you to memorize this. Okay, what I'm going to write, and that is that in the x components, in the horizontal components, going to the left is a negative direction, but going to the right position represents a positive direction. In the y components occurs something very similar. Okay, vertically, if you go up, it's something positive, and if you go down, it's something negative. Just imagine like in a football play, okay? Cristiano Ronaldo, when he jumps for a header, for example, that's something positive because he could score a goal. But if somebody else from the other team commits a foul to him, that's something negative because that's something that could injure him. Okay, so if falling down or going down actually represents a negative thing about the y component, about the vertical position, but jumping or going up, it's something good. Now, how are we going to be working to add vectors? So far, you already know how to add. For example, if I tell you how much is 8 plus 5, you already know how to get that, okay? Or you don't. Guys, do we need to go to first grade?
13.
You already also know how to add whole numbers that are part of the negative. For example, I tell you 5, negative 5 plus 8. How much is that? Take a look. That's an addition. Okay? We're adding.
0. 3.
Uh-huh. We're adding, but because we're adding a negative symbol in the end, this is a subtraction. So this is 3. That's right. You already know how to add. But I can tell you a sad story, and that sad story is that vectors we cannot add them as if they were numbers, whole numbers or decimal numbers. No. To add the vectors, we're going to use a method that is called components method. Okay? And that method is just using that table over there. That table, I will be sharing it with you. Now, the idea of this, um, wait a second. Now, the idea of adding the vectors, it's very similar, but it's not the same. Okay, it's not the same. I'm going to delete a few things from the table because I need space to work. Well, this is what I call my liquid paper. Okay, it's supposedly funny, but it's okay if you don't laugh. Sorry, I'm using my bare hands right here. I don't know what happened with the Acrylic pencil. Okay, so take a look. Here is a table that is composed of 3 columns. One column that is called vector. What you're gonna put in that color is actually in that column is actually the vector. I'm going to teach you how to do it. Honestly, it is simple, but it requires time. Now take a look. I have two vectors in my Cartesian plane. So what I'm going to do is I'm going to put them right here. Okay, my vector A is just an arrow that has an angle of 40 degrees and measures 100 Newton. Okay, that's my vector A. If you can see, I'm just including the most important information over there. For my vector B, it's an angle that is going in this direction that measures 80 Newton and has an angle of 30 degrees. All I'm doing there is putting the vectors separately, okay? To treat them in separately. Now, take a look what I'm going to do. Remember what I told you in the last class about the angle and the vectors? I told you that we care about the position of the angle. Remember when I say that, right? So take a look to the vectors. If I draw the components of each vector, you will notice that what I have here is a right triangle, and that what I have over there is also a right triangle. If I have right triangles, means that I can use the Pythagorean theorem. That's why I taught you the other topic before I can go into this. Now take a look. My angle. For my vector A, my angle is here. Tell me, how is this side according to the angle? Is it opposite or is it adjacent?
Opposite.
It is opposite. That is very good. Okay, take a look. I put the SOHCAHTOA over there because we're gonna use it. Now, take a look. My side, AI, my component Y for that vector is opposite to my angle. Now, which one between SO and CA uses the opposite side? Which one uses the opposite side from the definitions? Remember what SOHCAHTOA means, right? The S is for sine, the O that is for opposite, the H that is for hypotenuse, the C that is for cosine, the A that is for adjacent, and the H that represents hypotenuse. So, which one between SO and CA, between sine and cosine, what trigonometric function uses opposite?
So.
So, okay, so take a look here. So, sine opposite hypotenuse. For this side AY that is opposite to the angle, I'm gonna use the trigonometric function sine, okay? Because my side is in front of the angle. Remember, we care about the position of the angle. Therefore, the remaining side is going to be my adjacent side. So, take a look. For my y component, this is all I want you to see. For my y component, I'm gonna be using the trigonometric function sine. So I say, for my y component, I say a y. Now this formula is not going to change, but I want you to see where it is coming from. For a y, my component is equal to my hypotenuse times the sine of the angle. The reason is because the AY, the side Y, is opposite to my angle. And for my X component, that is AX, is using the adjacent side. The adjacent side is for the cosine. Okay, so for AX, I'm gonna be using this formula: hypotenuse times cosine of my angle. Now, the hypotenuse is always given in this kind of exercises. The hypotenuse is the vector. Okay, so the hypotenuse is 100 Newton. The reason is because it is opposite to my right angle. Remember that rule, okay? The hypotenuse is always opposite to the right angle. So the hypotenuse in these exercises are always going to be given. So we're going to replace hypotenuse by the value that is 100 Newton. So we say AX is 100 Newton times cosine of 40 degrees. How much is this? In your calculator, you're going to do the following. Give me a second. I don't know why you have the camera off, Kenneth. So in your calculator, what you're going to do is, make sure that it is in degrees, okay? And just press this, 100 times cosine of 40. This gives me 76.60. And the units are, in this case, Newton, because the vector is Newton, okay? That's why I have Newton. Now, I want you to tell me the component here, where is it going? Is it going to the right or is it going to the left?
To the right.
It is going to the right. And because it is going to the right remember, is positive. So you have to indicate the sign. Positive because it is going to the right. And please put the positive here. You have to put it in the two sides. In that way, you're not going to mess it up. Now, for the y component, we apply the same formula. Well, similar. So we replace by the given 100 newtons times the sine of 40 degrees. Take your calculator with you and apply the procedure. 100 times sine of 40 degrees equal. Did you get the same answer? And again,
Yes.
the answer over there is in Newton. Now, let's analyze where it's going. We already did it before, okay? But where is this component going? Is it going up or down?
Up.
Up. Because it's going up, we're going to put the direction over there. It's going up, so it is going to be positive. And please put the sign in front of the answer. What we just did right now is, we can say that we finished the first vector. Now we need to continue with the other vector. Now, this topic is amazing. I can give you 20 vectors and you will have to do 20 procedures to get one answer. So according to the number of vectors, you're gonna do a long or short process, because here we have just two vectors. It's going to end in here. Okay, it's going to be a simple process. Now let's analyze the direction. Bx, the component x of that vector is going where? Right or left?
Left.
Okay, it's going left, so it's going to be negative. I know I put positive, sorry. So it's going to be negative. So I want you to put the sign right here, negative, because it's going to the left. In that way, you're not going to forget. Now, by. Where is by going? Is it going up or down?
Up.
It's going up. Okay, so it's going to be positive. So in the table, you're going to put the positive because it's going up. Okay? Going up. It doesn't matter how you put it up, honestly. Okay, now we're going to get the components. Bx and by. Remember, we care about the position of the angle. How is by according to the angle? Is it adjacent or is it opposite? How is by according to the angle? In front or touching the angle?
It is opposite.
It is opposite. So because it is opposite, we're going to be using sine. Okay? So in the formula, by is going to be hypotenuse times the sine of the angle. And bx is going to be the same, but using cosine of the angle. Okay? Now remember, hypotenuse in this case is not 100, it is only 80. So here the hypotenuse changes and also the angle changes. Okay? So this calculation is going to be 80 Newton times cosine of 30. How much is this? Remember that we already indicate that is negative, okay? So I'm gonna put the negative over there. How much is?
69.28.
Just remember to do it with me. 80 times cosine of 30. Close parenthesis equal. And there's the answer, okay? Remember that it's negative, so leave it there. And you put the newtons, do not forget. Now for by, you're gonna do the same process. Substitute by the givens that are 80 Newton, sine of the angle that is 30, and this is equal 40. To positive 40 Newton. With this, we said that we finished the two vectors, but it isn't over yet. Take a look. The table tells you what's next. That symbol over there indicates that you need to add. Okay? How are you going to add? You're going to add each column. Okay? So you're going to add the 76.6 with the negative 69.28. So your calculator will be 76.60 minus 69.28. And this gives you 7.32. As you can see, it's positive 7.82. Okay, so the positive and the 7.32. Take a look. because this column is the x component, here you're going to put that this is the result for x, and it is positive 7.32 Newton. Now for y, you're going to be doing the same. You're going to add vertically 64.28 plus 40, and this is going to give you 104.28 Newton. As you can see, it is positive. Now take a look to this equation right here. Does it look similar to something that we already seen in class? Does it look familiar to some equation?
It looks like the formula from the last topic that we see of the
Exactly.
triangles.
It is an application of the Pythagorean theorem. That's why I told you the Pythagorean theorem before, okay? So take a look. This equation here is based on that formula. And these are actually represents the word resultant. Resultant is the addition of the vectors, okay? It's the result of adding vectors. That is the resultant. So how do we do it? Applying the formula that you see over there. Now take a look. X and Y are here, okay? Those are the X and Y that you have to use. So in the formula, it's going to be the square root of X, that is 7.32 newtons, raised to the second power, plus Y, that is 104.28 newton, raised to the second power. Remember, we do this entirely with a calculator. We say 7.32 squared plus 104.28 squared, and that is the result. We do it step by step. Okay, so this is the square root of 10,000, sorry, 10,927.90, and these are Newton to the second power. The second power of the Newton is going to be cancelled with the square root. And now we're going to apply the square root of 10,927.9 in a calculator, which gives you 104.54. So you put the answer over there, 104.54, and these are just Newton. So the result of adding the vector a plus b is 104.54 newtons. But all the vectors, as you can see, have a value or a hypotenuse and an angle. To get the angle, we need to apply this formula. This formula, I gave it to you before as an arctangent of opposite over adjacent. I don't know if you remember. Again, it is an application of that formula. So this is known as the angle or direction, okay? And you just apply the formula. So you say the angle is equal to arctangent of y divided by x. Y, that is 104 point, let me see, 0.28 divided by x, that is 7.32 Newton. With this, you cancel Newton and Newton, and you apply the formula in the calculator. So this is going to be arc tangent, shift tangent of 104.28 divided by 7.32, close parentheses. Did you get the same result as me?
Yes.
So the angle that I obtained was 85.98. And because we are talking about angles, this is going to be in degrees. And what I just did right now is finishing the exercise. Take a look, it requires a lot of work. And one mistake, for example, in the signs, in this step right here, for example, if you forget to put the negative over there, everything is going to be incorrect. Now, in a quiz, how I check this? I check it like each component. For example, I check each value, each value, each value, each value, like that. For example, one exercise of this topic could be from 8 up to 10 points in a quiz or in exam, because it requires a lot of work. I'm going to send you a video where I solve another example so you can watch it again. I will post this video in YouTube and also in Classroom so you can watch it again. And I will assign homework for you to practice. Any doubt, send me a message. Please keep your calculators with you when you are in my class, so you are doing the same procedure as me. Thank you.